Hello students, welcome to BioWise with Aanchal. Today we are going to study about atomicity and valency, the topic which is very important to understand the basics of chemistry. And at the end of this lecture, you will have some important questions that is required for scoring full marks on this topic in your examination. So stay tuned with me till the end to understand the concept and then answer the questions accordingly. Do tell me how much you have understood in the comment section. So let us begin with the topic, that is atomicity. Now if I say atomicity, we are talking about molecules. Okay, when we are talking about molecules, we are talking about the group of atoms. So as you know, those who have attended my previous lesson on atomic structure and even on formation of ions, you know that there are two types of molecules. What are those? One is a molecule of an element and one is a molecule of a compound. Molecule of a compound. So when we talk about the molecule of an element, then how these elements exist in nature independently. Understand the difference between an atom and a molecule. Atom may or may not exist independently, but a molecule exists independently. When I was talking about hydrogen in my previous lecture, if you remember, H cannot exist independently. Hydrogen atom H, but when you say hydrogen gas, that is H2, it has independent existence. So in all the chemical reactions, the reactants and the product has to be molecules. So when I say oxygen gas is released in certain reaction, when you are writing a chemical reaction, you need to write O2. When you are writing hydrogen gas is released, you have to write H2. So let us understand what is atomicity. So atomicity is basically the number of atoms present in molecules. Present in a molecule, right? If I say water, H2O, number of atoms present here is 2 H atom plus 1 O atom, that is total it has got 3 atoms. So atomicity of H2O is 3. Always remember, whenever we talk about atomicity, we are talking about molecule. It can be a molecule of an element like hydrogen, oxygen, nitrogen, ozone, phosphorus, sulfur, helium, iron, copper, right? So you can see that some elements exist in single atom form. So here even the atom forms, you can say they are independent, they are of independent existence. And here you can see there are 2 atoms of hydrogen which makes 1 molecule of, 2 atoms of oxygen which makes 1 molecule of oxygen, 2 atoms of nitrogen make 1 molecule of nitrogen. So atomicity of hydrogen, oxygen and nitrogen is 2. And here they are polyatomic. Ozone atomicity is 3, phosphorus atomicity is 4, sulfur atomicity is 8. Is that clear? Let me rub the board to understand it better. When you have to define atomicity, it is the number of atoms present in a molecule. Now when you talk about a molecule of an element or a molecule of a compound, you should know valencies to form the compound, that is true. But after the formation of the compound, what is the number of atoms present in it gives you the number which is atomicity. So based on the number of atoms present in a molecule, you can have the molecules as monoatomic, diatomic, triatomic, and polyatomic, that is more than 3. Okay. Now first let me tell you about the molecule of elements. So always remember that no PlayStation, right? Being a teacher, I can tell you that no games. So remember in chemistry, no PlayStation, no. Okay, that is no, NOHH, PlayStation. What is no? No are the diatomic molecules. And what is PlayStation? PlayStation now is polyatomic. Rest all except for ozone, that is O3, rest all are monoatomic. Let us see. We discussed about the first 20 elements. Before that, we need to know the full forms. Why I have used no PlayStation? No PlayStation, N is for nitrogen, that is N2, oxygen, that is O2, hydrogen, that is H2, and another H is for halogens. Halogens, what are halogens? If you remember, that is group 17 elements. What are the group 17 elements? Fluorine, chlorine, bromine and iodine. So these all are diatomic. No. Nitrogen, oxygen, hydrogen and halogens. Halogens are group 17 elements, that is fluorine, chlorine, bromine and iodine, right? And PlayStation is phosphorus, that is P4, and sulfur, that is S8. Clear? Now, for this detailed notes, the link is given in the description. You can download it for free and study, and my reward is when you score good marks in your examination, right? Now, leaving these, whatever is left behind is a monoatomic molecule. For example, all metals, all noble gases, right? Then you have got some metalloids, right? And then you have some non-metals too, because all non-metals are not here. For example, if I say metals, okay, metals like lithium, beryllium, boron is a metalloid, carbon is a non-metal, nitrogen, oxygen, fluorine, neon, neon is a noble gas, sodium, metal, magnesium, aluminium, silicon, that is boron and silicon, then phosphorus, sulfur, chlorine, argon, potassium, calcium, right? These are all monoatomic. Is that so difficult to understand? So, whenever we talk about atomicity, we talk about molecules. And what of molecules? How many atoms are present in a molecule? These all what I have talked about is about the molecule of an element, because you can see they all contain same kind of atoms, 2 atoms of nitrogen, 2 atoms of oxygen, 2 atoms of hydrogen, 4 atoms of phosphorus, 8 atoms of sulfur. So, they all contain same kind of atoms, they are the molecule of element, right? And in molecule of element you have to remember no PlayStation. No is diatomic, PlayStation is polyatomic. Ozone, you have to remember, it's another form of oxygen only. So, ozone has got 3 atoms of oxygen. So, any question based on this, for example, if I give you a say atomic mass of one oxygen atom, okay, one oxygen atom mass is 16 AMU or 16 unit. What is the mass of ozone? Until unless you know that ozone is a triatomic molecule, you will not be able to calculate the atomic mass of ozone, right? So, that is the application. Is that clear? You can take a screenshot. The notes are given in the description, and there is also a Google form in the description which you can solve to understand and test your understanding. Okay? Now, let us move ahead. Let me clear the board. Now, we will discuss about the atomicity of compounds. Now, I will start with very simple compounds, and you can pause the video for a while, write the answer in the comment section, and then check whether you know the answer or not. Okay? Now, first one, as I have already told you, water. So, what is the atomicity of a molecule of water? That is 2 atoms of hydrogen and 1 atom of oxygen. Atomicity is 3. Carbon dioxide, 1 atom of carbon and 2 atoms of oxygen. Atomicity is 3. Correct? Next one. Let us have ammonia. Write the answer in the comment section. What is the atomicity of ammonia? Next one, let us have calcium carbonate. So, calcium, 1 atom of calcium, 1 atom of carbon and 3 atoms of oxygen. So, 1, 1 and 3, 3 plus 1 4 plus 1 5, right. Then you have say aluminum chloride. Okay. Why I am writing this, we will come to know when we understand valencies. Okay. So, aluminum chloride, 1 of aluminum and 3 of chlorine. So, total 4, right. Phosphorus pentaoxide. So, 2 of phosphorus and 5 of oxygen, that is 7, correct. Last one, CH4, that is methane. So, 1 carbon and 4 hydrogen, total 5. Clear? Any doubt? I hope you understood the concept of atomicity. Any doubt, put it in our comment section, I will get back to you, right. Let us move to valencies. So, next topic is valencies. What is valency? Valency is the combining capacity of an atom. Now, when we are talking about atomicity, we were talking about the number of atoms present in a molecule. But what decides this number is basically the valency. The valency is the combining capacity, right, and it depends upon the number of electrons present in the outermost orbit. Those who have seen the lecture on atomic structure, you know that every atom has got a nucleus followed by shells, K shell, L shell, M and N, correct. So, you have got K, L, M, N. Number of electrons present in this is determined by a formula 2n square, where K can have 2, L can have 8, 18 and 32. Okay. Now, here also when we are studying the first 20 elements, we have to see that maximum comfortable arrangement 8 is the maximum electron that we are fitting in the last orbital. Then anything extra we move ahead. We explain you with an example like argon, how we represent an atom, atomic number that is 18 and mass number that is 40, A to Z, right. Here A is 40 and Z is 18, and this is an argon atom representation. So in this case, argon has got 18 electrons, proton is 18, number is always equal, you know that, and neutron is 22. So when you talk about the electronic configuration, you know that K shell can accommodate only 2 electrons. So K, L, M, N. 2 in K, then L can accommodate 8, 8 plus 2, 10, M has got 8. That is the electronic configuration of argon. What is the electronic configuration? 2, 8, 8. So when you move ahead, that is after 18 you go to the 19th element. 19th element is potassium, atomic mass 39. The electronic configuration of 19 electrons will be 2, 8, 8, 1. So this one electron moves to the N shell. Is that clear? Similarly for calcium that is 20 and 40, the electronic configuration is 2, 8, 8, 2. Right. So valency depends upon the last shell, how many electrons the last shell has got. Okay, that determines the combining capacity of an element. Like if potassium has got 1 electron in the outermost orbit, then it will be able to have, it has only one hand, you can say, right? But when calcium has got 2 electrons in the outermost orbit, you can say it has got 2 hands. Is that clear? Let me explain you in a better way. Yes, so before understanding the valencies and all the other elements, let us understand the valency of the first 20 elements and how the filling of the shells determine the valency, right? So you know that hydrogen, I will write that is hydrogen, atomic number 1, mass 1. So electronic configuration is 1, right? So the valence shell, that is K shell, has got only 1 electron. So valency of hydrogen is 1, because hydrogen can give away this 1 electron or take 1 electron to make it similar to the helium, that is 2. Okay. So for helium, that is 2 and 4, the electronic configuration is 2. Now in this case you should remember that K shell is full. So whenever a shell gets filled, the atom does not want to give away electrons or take electrons. So the valency becomes 0 because they are chemically inert, they do not react, it is a noble gas. So valency is 0. Clear? Then you have got lithium, that is 3 and 7, electronic configuration 2, K shell is full, L shell starts getting filled. So valency is 1, because this 1 electron determines, no, it has to be lost. So a valency basically is number of electrons lost or gained so that they can get the stable electronic configuration and participate in chemical reactions, formation of compounds. Okay. Then beryllium 4 and 9. So it is 2, 2. So since 2, it can lose 2 electrons, valency is 2. Boron 5 and 11, 2, 3. So valency is 3. Carbon 6, 12, 2, 4. 4 electrons in the outermost orbit. So in order to be stable, carbon needs 4 more electrons, right? So carbon has a tendency to share electrons to complete its octet. It does not form ions. In the previous lecture we know that, right? So here the valency is 4. This is the maximum valency an atom can have, correct? Then you have got nitrogen, that is 7 and 14, that is 2, 5. right? Now 5 means it has got 5 electrons in the outermost orbit and it requires 3 more. Now you tell me whether losing out 5 is easy or gaining 3 is easy. Gaining 3 is easy. So nitrogen will prefer to gain 3 electrons. So how many electrons it is sharing? 3. So valency becomes 3. Correct. Similarly, when you talk about oxygen, that is 8 and 16, 2, 6. So how many electrons it requires? It requires 2 electrons. So valency becomes 2, right? Fluorine 9 and 19, that is 2, 7. Valency is 1. Neon, that is 10 and 20. In this case 2 and 8. So L shell also gets filled. So it is a noble gas. So valency is 0. Okay. Now when you talk about sodium, 11 and 23. 2, 8, 1. That is after K, L, M shell starts getting filled. So valency is 1. Magnesium 12 and 24, that is 2, 8, 2. Valency is 2. Aluminium 13, 27, 2, 8, 3. Valency is 3. Silicon 14, 28, that is 2, 8, 4. Valency is 4. Same as carbon. Phosphorus 15 and 31, that is 2, 8 and 5. Valency is 3. Correct. So till 15 we are done. You understand, children, you observe, whenever in the outermost shell you have the electrons as 1, 2, 3 and 4. The valency is 1, 2, 3 and 4. And whenever you have 5, 6, 7 or 8, you have the valency as 8 minus 5, 8 minus 6, 8 minus 7 and 8 minus 8. So 8 minus 5 is 3, 8 minus 6 is 2, 8 minus 7 is 1 and 8 minus 8 is 0. Is that clear? So if you have understood the concept, so now you tell me after phosphorus you have sulfur 16 and 32. So electronic configuration is 2, 8, 6. 6. So what is the valency? 8 minus 6, 2. So after sulfur you have chlorine 17, 35. You have 2, 8, 7. 8 minus 7 is 1. So valency of chlorine is 1. Argon 18, 40. 2, 8, 8. Now the M shell is now full. So here the valency 8 minus 8 is 0. Right. Potassium 19, 39. 2, 8, 8, 1. Outermost shell has 1. Calcium, that is 20, and 40. 2, 8, 8, 2. Valency is 2. Right. Is this clear to you how the valency is being decided? So you need to know the electronic configuration, which is not that difficult to remember. Right. You need to know the atomic number. Now I have already told you in the beginning of the sessions that you need to know the first 20 elements by heart. Atomic number is number of protons. Number of protons is equal to number of electrons. Electrons has to be divided in K, L, M, N shells based on their capacity. So K has the maximum capacity of 2, L has got 8, M has got 8, and for potassium and calcium put it in the N shell 1 and 2. When in exam the question is asked that what is the capacity of M shell, then you have to write 18 2n square. This formula has to be used to find the capacity. Now this is very basic to understand. If I have a room where I am teaching you right now, it can have the capacity of 10 people, right? But maybe 4 can live comfortably. That is a basic thing that you need to know till your 10th standard, right? So M has the capacity of 18, but it is happy with 8. So when capacity is asked, write 2n square, and what is the number of electrons present in any atom, then you write accordingly. Is that clear? Any doubt? No? Let me move ahead. One way of learning the valency is based on the electronic configuration, but how many electronic configurations you need to solve? So if you know the periodic table, then also you can find out the valency, because all the, you can see, you say it, no, birds of same feather flock together. In chemistry also, all the elements of similar structure are together, okay, except hydrogen does not follow the rule. Anyway, so you know that we have groups this way and we have got periods this way, correct? So you have group 1, 2, 3 to 12, that is the transition elements. We are not studying it, we are studying only the first 20 elements, so we do not need the transition elements right now. 13, then you have got 14, 15, 16, 17, 18, okay. All have been given names, like one is called the alkali metals, 2 is called the alkaline earth metals, metals only, okay. Then you have this oxygen family, then you have this nitrogen family, carbon, group 14 carbon family, then this is your boron and aluminium family. Specific name is given to this is called halogens. You remember the NOHH, last H, that is halogens, and this is a very shant wala bacha, that is noble gas, does not react, okay. So valency is 0 for it. Now when you see the last unit digits, that determines the valency, okay. So if you have 1, 2, 3 and 4, the valency is 1, 2, 3 and 4. And if you have valency 5, 6, that is if you have the number as 5, 6, 7 and 8, then the valency is 8 minus that number, fine. So if you remember the periodic table, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then you have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium, correct. Now when you see this group 1 elements, and what we have done before, you can check your notes if you are writing it. It's better what I write on the board, no children, you keep writing it. Have your running notes ready with you. So in exam time this is going to help you, right. So now you can see here group 1 elements, hydrogen, lithium, sodium, potassium. In my atomic structure video, in the description I have given you mnemonics to remember the elements present in the groups. So you can go there and find out and learn the same. So Leena ki rabdi sasti and free, beta mange car, scooter, baap razi and so on, right. So they have the valency 1. Similarly, beryllium, magnesium, calcium group 2 elements have the valency 2. 13, 3, so valency is 3. This one valency is 4. 5, so 8 minus 5, valency is 3. And 16, you have 8 minus 6, valency is 2. 8 minus 7, valency is 1. 8 minus 8, valency is 0. Since valency is 0, combining capacity is 0, they do not react. Their outermost shell is completely filled. So they are not interested to form any kind of bond with anyone. Fine. So you can again see an order here. 1, 2, 3, 4, 3, 2, 1, 0, and it continues. 1, 0, 1, 2, 3, 4, 3, 2, 1, 0, 1, 2, 3, 4, 3, 2, 1, 0, 1, 2, right. So this is the valency. Valency is very much required for you to learn. Reason is you can form formula on the basis of valency. How is that possible? I will give you one example, then the last question, and we will end up the lecture. Okay. If I write aluminium, and chlorine. Please refer the notes that you have taken. What is the valency of aluminium? 3. What is the valency of chlorine? 1. So chlorine has got only 1 arm and aluminium has got 3 arms. Now aluminium has got 1, 2 and 3 arms, but chlorine has got only 1 arm. So 3 chlorines are required to fulfill the requirement of 1 aluminium. So what we do, we write 1 here and 3 here and form the formula AlCl3. Is that clear? Aluminium has got 3 arms and chlorine has got only 1 arm. So to satisfy the need of aluminium, 3 separate chlorines are needed. So the formula is AlCl3. So valency is written crisscrossed. Aluminium valency is written with chlorine because there are 3 chlorine atoms required, and the valency of chlorine is written with aluminium. You can see only 1 aluminium atom and 3 chlorine atoms are there. Is that clear? One more example. That is water. Simple one I will take. So hydrogen and oxygen. What is the valency of hydrogen? 1. And what is the valency of oxygen? 2. That means hydrogen has got 1 arm and oxygen has got 2 arms. Correct? So for every 1 arm of oxygen, you require 2 atoms of hydrogen. It makes H2O. How H2O? 2 is written with H, 1 is written with O. 1 we generally don't write. So the formula is H2O1 and 1 we don't write. So the formula is H2O. Easy? One more. The next one, let us take sodium oxide. Sodium oxide. Sodium valency, symbol is Na, oxygen O. Valency of sodium is 1, oxygen is 2. Correct? So oxygen has got 2 arms and sodium has got only 1 arm. So 1 arm of oxygen, 1 arm of sodium, similarly 1 more sodium. So you have got Na2O1. So 1 is not written, so you write Na2O. 2 atoms of sodium and 1 atom of oxygen. Clear? Yes. Now the surprise that you are all waiting for, that is the question important for your exams. Now the question is, if X is a random element, forms a compound that is XCl3. Okay, XCl3. So what is the formula of its oxide? Okay, and also calculate the atomicity of the compound. Also calculate the atomicity of the compound. Okay. So now what is the answer? Anybody who could write the answer, pause the video, solve and then try to find out the answer. So let us solve it. Now the given compound is what? XCl3. You know that the valency is interchanged and written. So in this case, valency of X is 3 and that of chlorine, you know that it is 1. Yeah. So I have got the valency of X. Now I have to form the oxide of X. Oxide of X. So X and O. Valency of X is 3 and that of oxygen, you know, it's 2. So 2 will be written with this, that is X2, and 3 will be written with O, that is O3. So the formula of the oxide of the X is X2O3. And what is the atomicity of this compound? Atomicity of the compound, 2 atoms of X plus 3 atoms of oxygen. 2 plus 3, so atomicity is 5. All those who have got the right answer, give me a thumbs up in the comment section. Yes, that is all for today. Thank you and happy learning, children.